Sorry, I don't know. My this was just 1, 2, 3, 4, 5. Yes. One. It's like Professor Wako, you are joining with your phone and your laptop or what?
Yeah, because when this one disrupts, I switch to the other one.
Okay,
And
no problem. No problem, sir.
I tried to share.
Yeah, sorry. I've not. Okay, you can share now. I didn't enable it. Immediately I wanted to enable it. My network was misbehaving. I had to put.
Okay, sir.
Yes. Yes. Thank you, sir. So the age distribution, if you look at it, there are 20 of them. So the 20 are here. So we go to analyze. Go to compare means. Yeah. You see one sample t-test. We click on it, sir. Now you move age to as test variable. You will see under test value, you put 0. So you now change, say the other one is 33. What you are comparing with the mean of this one is 33. You now put 33 there. So the mean you are getting from the literature that you are comparing with your own sample is what you put here. Very simple. I click OK.
No options.
There's no need here because the option there, you can see. Yeah, the option there is something that is default. Yeah, we'll go and check it later. See. Here the something that you have to here again, new share. Share the output, the result window. Yes, thank you, sir. This is just it. This is just the answer. So the group, the mean for the group is 39.55. That is, if you add all those 20 ages together, and divide by 20, it gives us 39.55. So comparing 39.55 with 33. So that is what I would do is that if you look at it now, here again, if you remember the last one we did, I talked about the confidence interval. There are two things we have done here. There are two inferential methods presented here now. The t-test, can you see the t-test 2.365? If you remember, at 95% confidence interval, and that is the initial slide, the critical value of t, if the degree of freedom, which degree of freedom was it? Was it close to 30 or something like that? 1 degree of freedom, is it 20 or something like that? I think 30 is 2.0, 2.201. You will see. Let's say we apply, because this one, the sample size also is 20. So the degree of freedom is 19. And the value we have calculated is more than that critical value. It will be significant. Can you see now? So look at it. The degree of freedom 19. That's 20 minus 1. The P is 0.029. Is statistically, so you can see the age, the mean age, 39.55 compared with 33. The difference is statistically significant. So that one is the hypothesis test. But when you now come to confidence interval, you will see that I said, oh, somebody, I don't know, maybe it's Prof something, is echoing my voice. Prof, one of your vessels is echoing my voice. Okay, thank you. So if you remember, when we discuss odds ratio and relative risk. When we talk about confidence interval, we use 1 because odds ratio and relative risk is about division. You divide one risk by the other risk, relative risk. Your odds ratio is dividing, is the same thing as relative odds. You divide one odd by the other odd. So the division is the way of comparing the two. If the two are the same, when you divide them, it will be 1. If the numerator is higher than the denominator, when you divide them, it will be greater than 1. If the numerator is smaller than the denominator, when you divide it, it will be less than 1. If they are the same, it will be 1. So here, if it is 1 in that one, when you are talking of categorical, odds ratio and relative risk, it shows there is no difference between the two of them. That is why if our confidence interval, whatever you get, your confidence interval crosses 1. In as much as 1 means no difference, and if that 1 is included in the range of value within which you feel the population value will be, that shows that the 1 is one of the possible values, so it's not significant. That's how to interpret the confidence interval for risk. Therefore, difference between mean and proportion, you use 0 because you know that if, let's say, the mean we are welcome, Busola. If the mean you are comparing,
thank you very much, sir.
Yeah, welcome, yeah. If the mean you are comparing, they are the same. If, let's say, this one is 39.55 and the other one is 39 or 39.55 also, both of them are the same. When you remove 39.55 from 39.55, it will be 0. So if the mean are the same, when you remove 1 from the, if you look at it, even the one we are doing now is x minus mu. You are removing 1 from the other. If both of them are the same, the difference will be 0. So if you now calculate anything, look at the difference, mean difference here, 6.55. You can, if you remove 33 from 39.55, it gives you 6.55. That's the difference between the two means. But if the confidence interval now say, oh, even the difference is 6.55, but the difference, you are 95% confident that in the population, the difference will be between minus 7 point this to plus 20 point this. In as if forget about the range, if you got the give. In as mean that in as much that the confidence interval include 1 in the range. You know, for you to include 1 on a scale, okay, maybe let me just on shares. No, don't worry, don't on shares. I can just share my own. That is a scale here. -1, -2.
I cannot share.
Oh, sorry. You cannot see my share. Okay, on share. Maybe on share.
Okay.
You cannot see. Maybe it's your. You cannot see my own, right?
Yeah, I can see now.
And yes, you can see. Everybody yes. Should be able to see. So just like that. Then this one, 1, 2, this 2, 3, 4. Just this is a scale like that. To as much length you want to reach. This one can be minus, can be extend to any length. Now, this 0 value. So if you have confidence interval of the difference between me, that starts with a value that has minus, and I end with a value that has plus, it means that let's say -4 to +3 is telling you that in the population, irrespective, maybe the value you are getting maybe 2, maybe -2, the mean difference can be, because of course the mean difference will be in between the confidence interval, because the lower value will be less than the mean difference, the upper value will be more than the mean difference. So the mean difference will be anything from there. But it's telling you that in the population, you are 95. What you have just gotten is for the sample, but you are 95% confident that in the population it would be between -4 and plus something. in as much that it has crossed 0. So it can be anything, it can be -4, -4.8, 3 point something, -2. It can be any value, any equal, including 0 in between the two range. So 0 is a possible value. So it's not statistically significant. So you can see in the, I was making reference to this in the last week training I did on the odd ratio of confidence. I said that if it were to be mean, someone will ask a question, say, this one is say cross 1, so we say cross 0. The cross 0 has something to do with difference between mean or proportion, because the way you know the difference, you calculate the difference is by minusing. And if two things are the same, when you minus one, it gives you 0. That is why the reference point is 0. So if it crosses 0, it means that there's no difference. If the confidence interval crosses 0, because it's possible in the population that it can be 0. That's what it means. But for the, I don't know why this, something is called, the odd ratio, it can be, is about division, because that one, if you divide two things of the same value, it gives you 1. That is why 1 is the reference for that one. So in odd ratio and relatively, the confidence, if anything 1 means that there's no difference. So because it's about division, why this one is about subtraction. So this one is 0. 0 is the reference. That one is 1. If the odd ratio crosses 1, included 1, include 1 in the, there's no difference. But here, mean difference, we are talking of difference between mean. If the odd ratio crosses 0, if the mean difference crosses 0, it's not significant. I don't know if you have questions concerning that before we proceed. Any question? It's very clear.
Yes. Hello?
So
Hello?
I'm listening, sir. I'm listening. I can hear you, sir.
Hello?
I can hear you. Okay. Maybe you are muted. I'm not muted. I can hear you.
Okay. The conclusion you are.
I think the problem is with your hands, Prof. Hello? Hello? Can somebody hear me? I know that can help me. If you can help me, you can talk or mute yourself and talk. If you can hear me, anybody can hear me, or mute yourself and talk. Nobody is responding. Busola, can you hear me? Sorry, I don't know why the internet is misbehaving here. Can you hear me? Busola, can you hear me? Anybody can hear me? Just talk.
Yes.
Yeah. Okay, Prof, we could not hear you.
I'm trying to chat it.
Okay, but it's clear now. What your word is clear now. You can, as you are chatting, you can say it. It's
Okay, so the conclusion you read with it is different. It's different from
what?
the t-test. From the t-test.
Yes.
But because it crossed it's crossed
0. Okay, you can chat it. Chat it because the thing has started again.
It's from 0.7. From 0.76, the slide that Balogu shared is the mean difference, 95% confidence interval mean difference is 0.76 to 12.3 or something.
And it doesn't cross 0. Do you think it crossed 0?
So which means it crosses 0. Yes, it crossed 0.76 to 12 point.
Okay, let's look at it. Let's look at it again.
The output.
I'm coming. That's all. Okay, the thing went off. I think that one should be still with it.
Pay attention to the p-value as well. I think it's not significant. 0.029.
No, it is. It is 0.29.
Yeah, it's good. This discussion is good.
It's good.
0.29 may not be significant. It's greater than 0.05.
This is 0.
It has not crossed 0.
0.029.
0.76 is positive.
Okay, significant.
It's positive.
Okay.
No, let's just share the output.
Positive.
And okay, I should go and share the. Let me put the illustration because the illustration is very, very
The
important.
output.
Okay, I should go to output. Okay, Dr.
Yeah,
Prof,
the
share the
Balogun's
output with us, sir.
output.
Prof,
Okay,
share
all
the
right, no
output with
problem.
us.
All
Professor,
right.
talking them.
Okay, sir.
You can
I thought it's
override my
Balogun
own
that
output.
did it.
Even
Yeah.
can you see, sir?
Yes.
0.76.
Yes. Yes.
Okay, that was where. Let me first of all, I will go back to that thing I was doing. Let me go the one Dr. Balogun said. Dr. Balogun,
Okay.
0.029 is less than 0.05 now.
Which is
But the confidence interval is not in keeping with
significant.
the value.
Okay, let's check.
That's
It's
what I'm
it's
saying.
good.
That's
The
what
way
I'm
we are
saying.
discussing is good. Let's check. So where will you put? Okay, let me just because the other one I don't know why it went away. The other one I did because that's why it's a special class. I don't want anybody to miss anything. Because people that value what I'm doing and ready to pay for it, I value them also. Somebody sends something, I don't even know the person I'm also as well. I should send video of all the things I've done to him. I just say,
They try.
is he using juju on me or what? Yeah, using his chosen as well. I should send the video. Yes. Okay, look at this thing. Where should we put is 0? But you yourself, you know, you can write on this thing. Yeah, you can decide to write on this because I think I allow sharing unless if the thing has gone. I allow sharing. So you can, where should we put that is 0.75? Is it here or here? Is 0.76 you are talking of?
Between 0 and 1.
Okay, thank you. It's somewhere here. No, it's somewhere here, 0.76. Is that not so?
Yes.
0, let me write it down because space. 0.76.
Yes.
So as it cross 1, are you something move from here to somewhere? As it cross 1, as it cross 0?
You're already out of 0.
Eh?
You're already out of 0. It's out of 0. 0.76 is out of 0.
We were saying the same thing. They said that the thing must not include 0 in the range. So it started anything after 0 is 0.76 to something higher. So it has not crossed 0. 0 is not. Will you say 0 included in the range now?
Oh, I see.
It's from 0.76 to I don't know which value is here.
Yeah, it doesn't matter.
Do you understand now?
Or something. Yes.
Dr. Balogun, can you understand now?
Yeah, I'm clear with you.
So it's in tandem.
Yes. For anything to cross 0, it has to start with minus. It has to be on this side of 0, which is minus. And now cross to plus. That shows that it has crossed, it has included 0 in its range. But sometimes the problem you can have is that you can have a value that
it's clear.
is maybe your p-value, because this one also corresponds with the p-value. Maybe your p-value is exactly 0.05. The confidence interval may not, it may be something like 0.000, very close to that 0. And it will not give you p-value of 0.5, 0.05. That is just significant. Do you get the picture now? Or even the confidence interval we say is around 0. So the borderline, sometimes you may be confused. But in a real sense, for it to cross 0, it will have a value that it has included 0 in the range. Even if it starts with 0, it has included 0. That's a situation where you just see the p-value will just be 0.05. So in that case, the confidence interval may be 0 to something. It has included 0. Maybe the p-value just above 0.05. So I think it's very clear for everybody now.
Yeah.
Yes.
You know, that's why we need to pay special attention. Little thing we may just off our mind. And it's a matter of thinking, because for you to remember something, you must deliberate on it like this. That's why I like the question, because the mistake you have made now, you cannot make it again. You get the picture now. Another person will make it. You cannot make it again because you have already made it before. And you have seen, you have realized it. Some people may be arguing blindly. Yes, but unless you take time, because sometimes our eyes just keep, we overlook some things. That's why it's like that. So we continue. Now, that is the example we just did. No, that's not the example. This one, another one. This is the example we just do. Yes, this is the example for sample. Let's go to the next one. The independent sample T. We don't need to talk much about it because the formula you are seeing, that was what I used to illustrate the T generally. Yeah. We say the mean difference, Butola I came late. The mu minus mu1 is the difference in the population. That is hypothesized value. This one is the difference you observe value, observe difference. This is the hypothesized difference. If the null hypothesis is true, the difference in population should be 0. That is the mu1 and mu2 should be the same. If you minus it will be 0. That's why this one is out of the, it will always be 0. That's why it's out of the equation. There's no point putting it there. This one is standard error of the difference. So for independent group, 2 groups now, there are 2 experimental conditions that different participants were assigned to each. It is not necessarily experimental condition. So that's why it is used when there are 2 experimental conditions. There is 1 experimental group and 1 control group, or comparing means of group in an observation study. So that is why when we talk about study design, the aspect of those study design that affect your analysis is whether it's 1 group or 2 group or 3 group, 1 group, 2 group, or many groups, or even this group before and after, or their independent group. That's aspect that affects your disease. Whether it's experimental, whether it's observation, doesn't matter. Just give me 2 independent group or 2 peer group. That's all computer knows or statistic knows. So the aspect that is experimental doesn't really matter. Now let's look at this example. The table below shows the number of days lost to absenteeism per month over 15 months due to sickness in the mining and construction industry. Can we say that means number of days lost differ in the 2 industries? You know why I actually put, I don't want, because sometimes in my training, non-medical people also benefit. So it's not all the time that now everything is about medical. You now explain, oh, for you people that are non-medical people, this is what this one means. You now proceed. So that's why I just give an example, which everybody can understand. There was a time somebody came from Maiduguri, he's a lawyer. He's doing PhD in law. He said that they have told them to be doing experiment and quantitative research now. Before, all they were doing before, they were not collecting data like this. They just do all this focus group discussion. That's the research they do in law. They have not been doing quantitative research. They now say that they want to introduce quantitative research to law. So he came for the training from Maiduguri, came to Abuja. So there are many other people also from other fields that come. So now you can see now we have 2 groups, mining and construction. We want to see these are they are separate group of people. This is a mining company, this construction company. So this day lost to absenteeism by the workers. So in a month, in each month, these are the day lost to absenteeism. I think everything is 12 months. Yes, is it 12 or I don't know, but if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's around 15 months. So they lost to absenteeism. So we want to compare. Will you say that, which one will you say that lose more day to absenteeism? How will you know which one? So unless you calculate the mean number of days, and now compare. They are two separate. So if we apply the formula to calculate the average, you apply. This is how to. Let somebody read that one for us. Busola, are you connected to the for you? Let me just forward what I forwarded to you now, as somebody is connecting. This data set that we are using. Let me just forward it to your mail. You can download this straight. So when somebody, let me stop sharing. Let somebody share with us. You see, mean day loss to absenteeism. Day loss to absenteeism. That's the name of the data file. Day loss to absenteeism. And let's look at it. Why? Busola, I've sent it to your mail. You can check. I sent mail to you. I think some okay. You click on the double click on the day loss to absenteeism so that I can go and read it.
Yeah, I think I have it now. I don't know whether you can see it or.
We can see, but you have not read it. You cannot read it in SPSS to. Okay, share again. Maybe it's your sharing. Share again because it's showing us your file where you pick it.
Okay.
Share again. Yeah, we have seen it now.
Okay.
Yeah. So what? Okay, that thing you were saying about this thing. What you do? Click on that thing you were talking. Click on that variable view. Click on this minus something here. No, here, under value, other values, under value. Click on that 3 something. You have to come, you have to come to this place and click and now put 1 and now call it what you want to call it. You label here, you say add. Then 2.
Okay.
You label it, what 2 mean? You add until you do everything and now say, okay, it will appear like so. That is when you analyze it, you bring the name out.
Oh, I see. Okay.
So you have to go and put the something there.
Like doing it twice. Okay.
Yeah, okay.
Now, thank you.
You're welcome. So you can go to analyze.
Compare means.
Compare means.
Independent sample.
Yeah, independent. Thank you. No, the first one was 1 sample.
Yeah, because you know the mean of that.
Yes.
Okay.
Yeah, click on it. Day loss is your day loss. You see that is the quantitative variable there. Okay. Then the group is group. The group variable. What differentiate mining from is group? Yes. Okay. Move it on that group variable. It now give you question mark. How did you code it? Click on define group. So when we enter it, you have to know how you code it. I enter it 1 for mining and 2 for consumption. You have put 1.
Okay.
Put 1 there and put 2 there. The other one. You can put 2 first and put 1, but just put 1 first and put 2. Doesn't matter. Now I will show you. Just wait. If were to be, I didn't code it. I just put mining and this thing. I have to type it the way it is. If it is string, but it's not string because it's numeric. This one you are just seeing is the labeling, right? I've coded 1, 2. But if this thing, you have to And if you want to put it, you have to put it double quotation. Put it in quotation like this. If it is not numeric, you have to put it, otherwise you not take it. Like if you type male and female like that, or F, you have to put double quotation to capture. That is why it's usually good to code even your categorical variable. Code them and label them. So go on, sir. Okay. Okay. You will see it give us the mean for the mining, mean for construction. It is very clear that the mining is higher, 5.8, and construction is 3.7. So they lose more day in mining. And if you look at the difference, look at the mean difference here. If you remove D from this, give you 2.067. Just like the other time, you can see two methods of differential statistics here. The hypothesis testing is the one that gives you T. But I want to show something here. If you remember, one of the reasons or one of the requirements or assumption for using a parametric test, the second one after the data matter was follow normal distribution, the second one is homogeneity of variance. That is, the group you are comparing, the variance should not be different too much. Should be homogeneous. If there's not, because when you have different variance, they are not comparable. The mean are not comparable. And I will tell you the reason. This is very, very important. That is when you are doing your study, you must have equal sample size for each group. Some people just claim, no, it's minimum sample size. Once each of them meet minimum sample size, you can hear. No, it's because they don't understand statistics very well. Now, if you remember, I said standard error. Two things it does, apart from the telling you how the variability in the population. That if it's big, it means that that particular thing very much. If it's small, it means that it doesn't very much. But it's also tell you how accurate your estimate is. If your standard error is very small, it's so that your estimate in the sample, your statistic is very close to the parameter. If the standard error is very large, it means that your statistic is far away from the parameter. I don't know if I'm making sense. No. Now, when you look at that, you see that if, and we said the standard error is determined by sample size. When the sample size is very large, you increase your sample size, it reduces your standard error. It makes your estimate to be closer to the parameter. So when you now have two that have different sample sizes, the same thing we are measuring have different sample sizes. The one that has higher sample size is more precise. The one that have higher sample size will have smaller variance, smaller standard deviation, and smaller standard error. I don't know if you understand me now. So when they have the variance is not different, it's not number one, it's not comparable. That's what people don't know. So that is why anything, even either quantitative or qualitative, make sure when you're comparing group, it is better. Unless you cannot help it, it is better your sample size is the same. Because the one that has higher sample size is more precise. Whatever you are measuring is closer to the parameter than the one that has smaller sample size. So if you look at this one now, look at their standard error. It's not too far from one another. Can you see? Look at the standard deviation, look at the standard error. Yes, thank you. So, now, there is a test called leaven test to test if the variance is homogeneous. That is when you run independent sample, because you are dealing with two groups now. You will see, they incorporate the leaven test for equality of variance here. The 11th S4 test, it shows us that there's no significant difference in the variance, because if there's significant, the p-value will be less than 0.05. Can you see now? So it's telling us that these two groups are comparable. There's homogeneity of variance. The variance is not too far. Maybe tomorrow, to clarify this thing for you, I will share. Okay, we'll use, there's a data set I will share with other people because, hello? Somebody is talking.
Yes, Dr. Dolapo, it's me.
Okay, sir.
I'm just trying to draw your attention. I mean, sometimes in the literature, when you are doing an experimental study and you are selecting your control.
Go on.
Now, if we have to apply independent sample t-test, just like you have rightly said now, and the control you have is less in number than
more. Most of them is usually more.
Group. No, usually more. Okay, control should be.
Because they are easy to get. The control are easier to get, especially in case control self.
I know that there is a ratio that they said the test. Okay, the test group should be. There's a ratio that they were saying the test and control.
That one is case control. I will explain. Don't worry. That one is case control, so that I will tell you the reason. That one is case. It's applicable to case control. It's case control.
Okay, but in experimental study, it is what you are saying is that the experimental and control group ideally
let them be the same. Let them be the same. Size. Yes.
If you have a difference of 5 or 6, it doesn't matter.
It doesn't matter, but it's still part of it. That's where to be if you want to increase your accuracy. You know, yes. Don't you know that sometimes your p-values are the borderline? Okay. Yes, I mean, it's not so marked. Yeah. All those different, if your p-value difference is marked and all the no problem. But when in the city, when the things are the borderline, that if the thing is so significant or not so significant, yeah, no problem. But in the situation, your p-value can just call 0.5, 0.057. Yes, I mean, it's just above that 0.05. Your p-value can just be below also, although just significant by just, so you will see all those little things also contribute. So I will tell you maybe by tomorrow, I will maybe share that particular when we did the first training on how to use SPSS. You know, I shared this skin lesion with you.
Yes.
Yeah. So that skin lesion, if okay, maybe even we can even use this one we even read now, this Ebola something, because the male and female may not be the same. We may calculate, try to see the difference between male and female. Because when you see it, you will see what I'm saying. So the summer, the 11th test will be significant because the samples are not the same. It will affect the variance. You get the vision now. It will affect the variance, and it will say that the variance is homogeneous. We'll do that tomorrow. Now, you will see. We will talk much about that. The issue there is that this issue you are raising now. You know, many people when they are doing a study, many people do study to suit themselves, especially when the study is for commercial purpose. Yes, I mean now, if the pharmaceutical company want you to do study for them now to prove that the drug is effective, someone they will even affect your protocol. They will have even written their protocol. So if you want to say, well, this is what you want, this one they don't, because they know that, okay, if they say, just like say something expire, they say this food has expired, is expiring in August. They know that someone can see eat it in September, it's still safe. But as it's going away from the expiry something, the risk, even till December, but the risk is increasing. But when it is close, so sometimes they know that even the side effect of the drug, they believe that there's no drug that doesn't have side effects, but you can still cope. So they put in the commercial aspect. So you discover that people dot, but if you actually want to do something, you want to put it the way it is, the closer, you want to be closer to the reality. Those are the stringent measures. Concerning the case control, when you say it can double up to tetraple, the reason means that you remember when last week or 2 weeks ago when we were talking about case control for odd ratio, is used for rare disease. And we say that when the disease is rare, the value of odd ratio is close to that of relative risk. So the case control is even is used for rare disease. It's less expensive. But the issue there is that when the disease is rare, you hardly even find to even recruit people. For a disease now, you may not even get 20 cases in the whole country. You may have to even do multi-center study to gather them. Now, because of you want to look at some factors apart from you calculating the relative risk. You want to look at some factors that may be associated with the disease also. Apart from that one, you have used to separate the other factors that may serve as confounder or factor that may be related to disease also. And for you to run the factor there very well, small sample size will not work. So you can now, since the cases are limited, you can have more control. You select more control to jack up the sample size. In that case, when you are now running the factor, you run all of them together. You don't run them. When you are running the factor, that group factor also that divided into case and control is a factor there. All that factors are there. You run it together. When you are running your disease reduction, all of them is you are moving the effect of other confounder from that, the way they affect that factor to really know the effect of that factor you are studying. So in that case, you need higher sample size. So you can double your control. You can triple your control. You can tetraple your control. See, it's advised when you are it's more like that. It's too much. It will be dangerous. You see, they advise not to even go to the bed. It should not be more than that tetraple. That's the logic behind doubling the control. I don't know if you understand, sir.
Yes, I'm fully with you.
Yeah. So many people now do it in a situation where what they are studying, what the course subject, they are rare. The eligible control, they are plenty. You get more of the eligible control. But it's not with that effect also. But it's for when you want to log the thing sample size very small, you want to do like this, you want to do regression. But if it is to look at all those other associations, when you are doing that, it's affecting it. If you compare the two mean, it's not comparable. To be sincere with you, it's not comparable because the variance, there won't be homogeneity of the variance. Okay, we have said that one. Let's proceed. You will see that the t-test, we know this one is comparable now because it's not significant. So there's homogeneity of variance. Look at the t-test, look at the p-value, it's significant. But if, look at it now, it also gives you two options here. If equal variance assume, equal variance not assume. If you feel that equal variance, that is, if there is no homogeneity of variance, the p-value is less than 0.05. You can decide to choose the value down here rather than the value here. So then the p-value. So we now come back to the confidence interval. So there are two hypothesis inferential methods we have done here. The confidence interval and the hypothesis test and confidence interval. Look at the confidence interval. So let's look at it. Is it significant or not from confidence interval?
It doesn't include.
It doesn't include.
So significant.
Zero. Significant. Yeah. And one thing is that if it's significant with confidence interval, it will be significant with p-value also. So you can use them to check the examiner. So that is why if you do your study, especially for examination, you put both there. If you want to show this thing. Though there's no need putting both because we have already said that p-value, hypothesis test just give you p-value, significant or not. But the confidence interval give you the mean difference. Then the range of value within which you can find the population difference. And you can also detect if it is significant or not. Can you see? So threefold deformation, just like the way it operates in a risk ratio, is the same thing here. The way you operate in relative risk and odds ratio is the same thing here. The confidence interval gives threefold information, p-value gives one information. And that is why it's prefer. In Lancet, they don't want to hear p-value. You see, that's no place in medicine. It came from agricultural research when in the early 19s, when they just dichotomized study into significant and not significant. So they don't like it. But if you are going for exam, you know that some people, they cannot even interpret confidence interval. You put only confidence that you are to own it because the examiner have already failed somebody before you even come for exam. And you have at least changed them. They say that you have failed, if you have failed, unless you prove otherwise. Or if they say you have passed, unless you prove otherwise, don't defend that you should not pass. But if the person has already failed you before exam, you have already made up his mind, unless you prove. So that type of thing is difficult to prove. And in our environment where the teacher knows everything, the student doesn't know anything. So I don't know why somebody had to make up his mind that he has faced somebody before the person come and defend what he so that's just it. So in that situation, it's good to put both p-value and everything. After all, they don't even know how to they may not even know how to interpret the confidence interval. So when they say, where is the p-value? You show it, okay. You go your way.
Yeah. So, Dr. Lalapo, sorry. I just want to also chip this. I'm just looking at a situation where you are doing a study and hello, can you hear me?
I'm listening.
Yes, where you are doing a study and you are comparing two populations, maybe experimental control or two experimental groups.
Yes.
If at the level of comparing means you get a significant difference, what do you do?
Yeah, it depends on the nature of the study, the way it is. When you do it, we can still do the regression. You know, when the issue there is that when you are looking at, you can do regression. Can
you go further that, okay, at the baseline, when you compare the mean of two study groups, you got a statistically significant difference. Will it make sense to go ahead and start applying t-test and some other things?
Okay, yes. Let me, sometimes we mingle study design. Like there are some people, if you want to do experimental study, some people, they first of all make sure that, in fact, they sample. That's why they do randomized control. They say randomization is the hallmark of experimental design. Why they say that is that in randomization, both what you're going to use as experimental and control, they are the same group of people that you just select them at random. So if you select it, they don't differ. If they have to differ, it's just by chance. If you do that, just like you want to test a drug now, all the people that have the cases, you have recruit about 100, you now randomize them to 50-50. So if you try to look for it, you will not see any difference most of the time. You will not even see any difference. If you try to look at it, they won't be different when you analyze it at baseline. I don't know if you understand me now. So yes, when you now carry out your experiment, you now try to compare them. So if you try to compare them, you should now, if there was no difference before, you now find a difference. But there's another way. If you find yourself in that situation, you just said now, that you compare at the baseline and there's a difference. Yes. What you do is that when you now finish, you have to compare, because if you now compare again, you find a difference, that does not help us. You now compare pre and post. I don't know if you understand me now.
Okay. For
each of them, pre and post, that is where you now get your. So for the experimental group, the pre, there should be a change in the pre. And for the control group, there should not be a significant change in pre. Or if there is risk, the change in the experimental group should be more. The difference between and post should be more in experimental group. You get it now? And that is why in our most of our people, when they are doing experimental design, they compare pre and post, and experimental and control group at the baseline. Pre and post, they compare the post, they compare experimental. They also do pre and post to see in different way to see. But to be sincere with you, they can be different because but if you do randomization very well, it's there, but they can be. Because in randomization, they just say that, okay, the difference you observe is due to chance. If there's any difference, it's not because, you know, in experimental design, especially when it comes to treatment, many people, you are doing it for commercial purpose, even for publication, because I don't know, finding, see, positive finding is a finding. Negative finding, but people don't want like negative one. They want to publish positive one. And the journal also that are accepting paper, they are more likely to publish positive one. That's why people want to see positive result. And that's why if they see there's no, they don't feel okay, they dot the result. They are influence it. If it's for commercial purpose, like other, in fact, those ones they influence it. Like now, if you want to provide treatment now, you may go and select the one that will not improve and put in control. And put in then the dog you are testing, the one you are testing, the one that you know that will improve is that you put there. Or if you have a relative that is suffering from that problem, you may want to help. He's having problem with procuring drug. And I said, oh, okay, we are doing a study now. We enlist you. We now put that person in the drug. No, a lot of things. In that case, that's not randomization. But randomization means that whenever you find yourself, it's by chance. And that's why they bring in blinding, all those stuff. And
so the essence is that if
okay, is somebody share this one? Is somebody share this one, right?
This is somebody's proposal.
Sorry about it. Sorry about it.
So you were saying something.
So what I was saying is that in the real essence of it, if you do your proper randomization,
yes,
there should no
yes, you hardly see the difference
in mean. If you do
yes,
your planning very well, it should be the same.
Okay. But that's in there are some experimental design like the one they do in public health, because they cannot do the type of study they are doing. It's difficult to randomize. You now do quasi-experimental. Like for example, now you want to effect of something health education. You cannot do randomization. The randomization would mean that you have to select some people that are together and now randomize them into control and experimental. It's not like drug that people take inside. It's education that can filter. If you educate people, they can tell other people. So if you go to school and you will say you are doing peer, others for students, peer group, this education, peer education. You go to the same school, you give some the education, give the other. And the same school, in fact, if the school is in the same environment, all the things you told them, they will tell the other people. So you have to now select schools that are far apart, but they are the same in many things. In that case, you have not done randomization. There's no randomization because you are not the one that put them in the school. Those schools, they are naturally in those schools. You now study one group compared with the other group. That is quasi-experimental. You understand me now? You are not doing randomization. In that situation, you may find out that even though they say you choose similar school, you may still find out that you know all your parameters, all your variable that will be all of they will see different. They will see different, and that is where, for God's sake, for people they don't study. Like in public and all the experimental research me have analyzed is lie. They told lie. Big lie. Even some of them, after they tell lie, they have decision because they have already made up their mind that if somebody do the experimental effect of education, they already reserve this big score mark for that person. all of them, all the cooker people that did that, they got the distinction because they already give good mark because you did experimental design. Can you see why we are deceiving ourselves in Africa? So that's it. Me, I piss off with them, because to me, I discussed this issue in the last this thing came out. You know, Prof, you remember it came out in the last week training. Somebody was asking question in that line. They just say the experimental is gold standard. We gold standard. So it doesn't. Experimental design is no more rigorous as any other design. It depends. The rigor you put in depends on the way you do your study. So that's just it. So, and I think we'll discuss that later so that I will not use. Let's maximize our time because by 8:30 I stop. I have meeting by 8:30.
I have a question, sir.
Okay.
So now equal variances assumed and equal variances not assumed.
Okay, sir.
The p-value and the confidence intervals are the same. Assuming they were different, which one would we have chosen? Is it the one for equal variances assumed or equal variances not assumed?
Yes, because equal variance assumed because there is no different homogeneity of variance. There is homogeneity of variance. This thing is not significant. This 11 test, this F you see. If it's significant, it will be less than 0.05 here. No, this one is not T test, it's 11 test. Yes, I mean, the first two columns. It's testing the variance, if they are the same or not. It's telling us that the variances are not different now. So equal variances are assumed. You understand me now?
Yes.
And if equal, if let's say it's different, you're going to see difference in the value. It's because the reason is because there's no difference in the variance. If there's difference in the variance now, the value here will be different. What that means, sir? The values here
So
will
what
be
I'm
different.
asking is, in that instance, which one would we have taken? Is it
If equal variance, if I know that 11 tests, I will take the one equal variance is not assumed because the 11th test is showing that the variances are not equal. But not many people consider that anyway. Many people consider that. Right? That's just it. You know, those are the. There's many people do it to switch themselves. If they are different and the one is significant, the other, you choose the one that is significant and leave the one that is not significant. You know that. So.
all right? Thank you, sir.
Welcome, sir. So I think let's quickly before what's the time now? Before it is 8:30. You know that I'm in Kaduna. We are doing something in Kaduna. I'm not even in Abuja. So there was a meeting with the one the group. I usually host them also on the Zoom to debrief, to have meeting. They say 6. I say they say 7. Usually meet by 7. I say I have a training by 6 from 6. And I say when will it end? Say 8:30. That's okay. That meeting we are starting down by 8:30. So by I don't know if we still run because there's another one now for peer. Maybe we should leave that one to tomorrow.
Tomorrow.
Peer
tomorrow.
test.
Let's just do that tomorrow.
The peer test before we proceed to all those other things.
Tomorrow.
Any question?
We'll do that tomorrow.
Okay. You can stop sharing, sir. Yes, thank you. So any other question before?
Other question, we'll wait till tomorrow.
Okay.
Yeah, thank you.
Welcome, sir. So welcome. So this issue you were raising, when we get there, we trash it. That thing about that, we're talking about something initially. About that man within you.
Okay.
And when we go to that place, we discuss it. Okay. Yes, sir.
Thank you.
Thank you. That's 3 minutes to this 8:27. Hope we have learned something tonight.
All right.
Yes. Hope we have learned something.
Yes, sir.
I think it will be better tomorrow also. It will always be better the subsequent days. Thank you, sir. Good night, sir.
All right. Thank you, sir. Good night.
Thank you, sir. Yes, sir.